And welcome to Display Data.
Hey, we're just hanging out
Sunday
here.
edition.
Chilling on a Sunday in the office.
Yeah. All right.
Stuff going on
You
here.
wanted to show some stuff off, but I guess first we should say what this is. This is, we have a new board coming out.
We have a new board coming out. I'm getting back on some hardware that I've been needing to finish. So the Metro M4 Express. CircuitPython 3.0 Alpha is supporting it and supporting it pretty well. So it's time to release this hardware so that people can get their hands on it. And we've been kind of working on this on and off since about August actually of last year.
Yeah.
But chips didn't really ship until November. So it's been a couple months, but we wanted to get all the peripherals going and tested. So parallel clock and QSPI and all that stuff. The parallel camera connector and QSPI, and just getting all the little things that you have to learn about a new chip when it comes out, getting those all going and nice and smooth. So this is the beta hardware. So this is the design that we sent out PCBs for. We're going to get them sometime this week. It's very exciting.
Okay, so that's this top of the board.
Yeah, and this is beta because we're still learning everything about this chip. So we might change a pin connection. So this isn't final. And this is the back of the board, which Phil B did a lovely silk screen. He added, by request, I had asked him to put a little MOSFET on the back. This is honorary MOSFET board. And otherwise it's the same shape as the Metro M0 and the Metro Classic, except it features that SAMD51 Metro chip. SAMD51, 120 megahertz, Cortex M4, pretty sweet.
Yeah. So do you want to show this testing procedure?
Yeah, well, I showed some of the testers I'm working on today.
Okay.
I have
so
two
let's start
testers.
with the overhead.
So this is the M0 tester. I designed one nice tester for both the M0 and the M4, but I thought I'd show the M0 first because this one's actually a little more finished. So I'm using...
weird.
Oh, what?
Hey, remember when it started doing this in the past?
What?
It went blank.
It went blank?
Yeah. We'll see what happens.
Oh, yeah.
Remember when that used to happen a long time ago? It went blank.
Ooh. So we're really goth right now?
Yeah, but it's unknown why. Let's see if it comes back.
Well, it's that camera, right?
No.
No?
How did we figure this out last time?
I think we changed to a shorter USB cable, didn't we?
No, it wasn't that. Oh, maybe it was. No, that was the overhead, right? Yeah, let's just go to the overhead without that other one. Okay.
Okay.
Yeah.
Is that working now?
I guess so. It was when the two cameras were on. Okay.
That's exciting. Well, this is Display Data. It's rough and unscripted. So we got the Teensy 3.6. I like this for our tester boards. It's more expensive than just a plain, for the basic testers we use in Metro or a 328 chip. What's nice about this is really, really fast. And I'm using this to SWD program the chips, basically acting like a J-Link. So having a really fast chip here is important because I'm bit banging that the SWD protocol. And then this storage SD card holds the flash memory image that I'm going to program onto the chip. So the 51 here is 512 K of flash, and then there's a version that's 1 megabyte of flash. So you have to store that image somehow. So having it on SD card just makes it really easy for me to test and update the code. And I got character LCD output, which is really nice. And I use the RGB backlight to give info. So it's like right now, if I run it, it'll say error on connecting because and it'll turn it red, so something went wrong. And then here is another SD card. And this SD card actually holds the image that's going to be programmed into the SPI flash. So likewise, this is 2 megabytes. It's too big to store in chip. It's easier just to have it an SD card. These are so inexpensive to add on. And then I have an image of what goes on here. And this chip self-programs it. This can only program this chip because it's an SWD connection. And then this SD card programs this chip. So it's kind of weird because there's 2 SD cards, but it turned out that this is really the easiest way to do it. And then Dano has kind of hooked me up with a plastic plate and this 3D printed thing. We're still noodling around with it. This is a little bit still wiggly, so I have to hold it down. But if I press reset and then I hold it down nicely, it can go through the whole test. It's erasing the flash memory, which takes a while. The SPI flash takes a long time to program. and then it programs Circuit Python in it. And now you can see it's got the bootloader and Circuit Python on it running, and you can see it's even going through a little RGB color swirl to let you know that the code is good, and then it's blinking an LED to also let you know, like, hey, data is transmitting. So this is the M0, and you can see it only takes about 10 seconds to program it, which is really good.
It's dangerous. I'm gonna try this again.
You gonna try it again?
Yeah.
Okay.
Well,
Scary.
Desk of Lady is the rapid prototype of trying all the stuff. So
Yeah.
see how it goes.
We're actually doing a revision on the M0. So the reason that this is not the classic black is it's a prototype. We're revising the M0 board to have through hole. So the 2.1 millimeter jack through hole and the headers through hole. We originally designed the Metro to be like surface mount headers, but now that we have a selective solder machine, I actually like the through hole headers more. They're more durable. They don't wiggle as much. So moving to this big pin jack and through hole headers is what we're going for with the M0
Want to take some
here.
questions as they come in?
Yeah, sure.
Is there a version with an Ethernet?
There is. It's only a Mac. It's not a Phi. So it does have Ethernet. It's either the SAM E51 or SAM E54. We were thinking about the next version. There's going to be like a mega-sized version, which we're still thinking of a good name for. So it'd be just like this, but even longer. And that chip, since it's like you have so much more space, we were thinking last night, we were talking maybe having an Ethernet jack on it.
Yeah.
But again, you'd have to add, I don't remember the name of the chip because I looked one up. There's like, you basically have to spend an extra couple bucks to get the Phi, the part that actually does the conversion of the voltage signals and the inductor and all that. So it's not like, you know, the WIZnet chips that we have, they're pretty inexpensive. And they kind of do the TCP/IP stack and everything. So we're not quite sure yet. It's like, if we add Ethernet, you have to put the whole TCP/IP stack on.
So there's a few PHY, yeah.
Yeah, it's like, it's kind of like, yeah, it has Ethernet, but it's not like done. Like there's a lot of work you have to add in to make the Ethernet work, and we'd basically have to like program it in RTOS. It gets like really complicated really fast. So we're thinking maybe in a future version of adding Ethernet. Like we've seen like the Teensy 3, 5 and 3.6 have Ethernet. I don't think the 3.2 has Ethernet, but the 3.6 I think does. But the process of actually getting the TCP/IP stack all working, it's just not, like you have to do it at a very low level, and like it's not fun to run your own TCP/IP stack. Like you can do it, I've done it, I didn't do a good job. There's better ones out there, but it's very hard to just get that part. You have to get a lot of stuff with it. Anyway, so this is the M0 tester. This is the 3515. I've got these cup pogos. So these are good for, they cup onto these through-hole headers. So that's that. And then today I worked on the version for the Metro M4. So I'm going to put this away. And then over here, so this is the M4 version. Oh, another fun thing is, you know, this has USB host. And so I use the USB host to test the USB connection. So it can, I don't need to have, I used to do this all with like a Linux computer and would actually check for like a USB enumeration. But what's nice is with a USB host built in to the Teensy, I don't have to do that. So there's a couple of things that I did that was exciting. So I forgot to add pogo pins on the bottom of this board for the SWD connections. So I have, you know, the SWDIO like standard header up here. So I kind of just like made a little adapter. So next time I revise this board, I'm going to add the 2 pogo pins. I just completely forgot about them. But that's okay, because this works fine. So you plug this in, and then I don't have the this part attached yet. We have to like laser cut a piece here, so I have to hold this by hand for now. But that's okay. And Dean, who wrote the original code for bit banging SWD programming, updated it to support the SAMD51. So it takes a little bit longer, but it does work. So let me program this, and then I have to hold this down. But it's still testing, erasing that flash chip, programming it, doing that final erase, and then putting in Circuit Python. So The test code actually is an Arduino. It's an Arduino program that takes the image, the SD file from here, and programs it to the QSPI. It's just easier to do it with Arduino because you have such better low-level control. Because in CircuitPython you can't program like the flash itself. So this way it's very, very quick. You know, I'm done in about 13 seconds. And then this is a completely finished, you know, it has CircuitPython 3.0 alpha on it, has files on the SD, the SPI flash, and everything is tested, including the power supply. So this is like the silk screen looks like, so you can see. It's got this kind of cool highlight, and it will be gold and then purple. It will be the mask color after the first run. We're going to have to do the first run in, I think, blue or black, and then we're going to go to purple.
Yep.
I can even grab, if you want, I can grab the purple PCB sample. So if you want to show off the purple color.
Yeah, go for it.
They're over. I forgot to grab them. They're over in my bin.
So we call dead air in the biz.
So yeah, I got some sample color PCBs for the Circuit Playground, and we ended up not doing this. We kind of ran out of time, but this is the purple color that we ended up picking with gold. It's a kind of a matte purple, and it matches Blinka. So yeah, we didn't use this. This was just a sample PCB that we got, but it shows the what it looks like. I think it's kind of nice, purple and gold. I have the royal colors. There. It's kind of nice. So we'll probably have the M4 boards be a purple color. And then you thought maybe we could have purple on one side and pink on the other? Like
yeah,
Blinka. That'd
be like Blinka.
Cool. I think that'd be neat. Maybe like a pink belly.
Yeah.
Yeah, we'll see. I've never asked a PCB house if they can do two-side color, like one color on each side, but we'll find out. If it's possible, we'll do it.
Okay, Etcher M4, is it Arduino compatible?
It is Arduino compatible. We've written an Arduino plug-in for it. And last weekend I tested every shield that we sell, all of them work. There's like one, sometimes there's a little changes you have to make to the shield. Like
I know what someone's getting for Arduino Day. I don't know.
Yeah, it works with the shields. The shields that run 5-volt logic, I have a little jumper you have to cut to make it 3-volt logic, because this chip really doesn't like it if you give it 5-volt. Like, it doesn't break it, it just doesn't work. It just like halts, because it's like, hey, why do you have a 5-volt logic level on a pin? So you just have to convert it to 3-volt logic. But all of the shields that we have, there's a little trace that you can cut to do that with, so it's not too bad.
Okay. You all right? Got anything else?
I've got this like robot board that we've been working on.
It's not
this
out
is
yet.
super. I mean,
Don't ask.
we just got these together.
Oh my god!
But
it's a robot board.
Yeah, we showed this off on previous Desk Lady as I was designing this. This is something that a feather would plug into. So it's a feather shield, even though it has a chip on it. And the idea behind this was to have like a robotic helper that kind of does all sorts of stuff that people often do when they're making artistic robots. So it has 4 servos, 8 GPIO with analog input or like digital I/O, 4 capacitive touch pads that you can alligator clip onto. NeoPixel output with the output pin at 5 volts, so it's converted up. A speaker, Class D speaker for playing music. 2 motor drivers with current limiting, so you can drive 2 bidirectional motors, and then or like 1 stepper motor. And then this is a transistor driver. So this is like a Darlington high power transistor driver with built-in diodes, so you can use this for solenoids or a stepper motor, or like a DC motor where you only want to go one direction, so you get 4 of those as well. The stuff that's been a challenge for me is the power supply. I'm trying to add in some power supply protection circuitry, so I picked up a new chip from TI, and I don't know if it works or not, so we're gonna find out. And then all this stuff is actually managed by a Seesaw chip. So this SAMD21 takes I2C commands to run all these I/O pins, because there's never going to be enough I/O pins on a feather to do all this stuff. There's just too many pins that you need, because there's like 20, I think I did the math, it was like 30 pins or 28 pins were needed. And a feather, you just run out, especially on an ESP8266, which only has like 4 pins available. So this way it's all done over I2C, and a lot of robotics, you don't need it to be that fast. Like running your I2C at 1 megahertz, you're gonna be fine. Like none of the robots that I've seen people make like artsy robots out of need like precision control. And then if we do end up wanting to do quadratron encoder type stuff, this chip would do it for you, and it would like handle all the timing control. So it'll work out much better, I think, than using shift registers or just a plain I/O expander. I think the Seesaw is a lot smarter, so it can do a lot more. So that's that. That's what I got so far. So this is just a prototype. Like it doesn't even turn on probably. Like it probably catches on fire the moment you put it in.
No, one of those 3D printers.
It's like one of those 3D printers, but we're gonna get there. And I kind of like this sort of like octagonal look. So it's got stuff on every edge. So this is my prototype.
Okay.
That's what I'm working on.
All right.
But
I think I learned something with all these video feeds too. Yeah, it's always interesting.
Challenging. Okay. All right, so the Metro M0 tester updated, much better, much faster. Metro M4 tester ready to go. We're going to get the latest CircuitPython alpha release ready. As soon as those PCBs come in, we'll make them. So probably in like a couple weeks, we're going to get when everything comes in, we'll get those M4s out. And I know we have like a couple hundred signups on that board. Sign up. It's, I think,
go to adafruit.com and sign up.
Yeah, search for SAMD51. I think it's 3382.
Yep.
And type in your name, and you will get notified. And we're going to have a limit of 1 per customer when we first release them, but we're going to have a couple hundred. So it'll be like pretty nice.
Okay.
All right.
And that's that. That's the Late Ada. Bye, everybody.
Bye.